Hello and welcome back. Welcome back. I'm John, old YouTuber and PC gamer. I have to start my video like this because I have to see the time is running on the screen. So I know and have to wait like 1 second to talk. Now I press the start button on my video. Like this, then I have to watch. We have some numbers there. It's changing to 1 second. But I'm recording with this camcorder because that's my only camcorder can record like this. Text like this. But I got a break and did upload my video. And even I made a video on Dennis. But that's about politics, that's about poor people in Denmark on welfare. We have record number of poor families with children on welfare. They have applied for help this summer. They apply for help to money, to food, and they go vacation on their children this summer. That's because we have this inflation and we have a lot of the prices of energy, electricity is rising, and food and bread and everything. So they had a hard time with money the last many years before this. Then we have the coronavirus 2 years, and then we have the war in Ukraine. So that's my video, Dennis video. About that I just made in my Twitter, so let's close my Twitter. That's the video I just made there. Let's close it, open my PDF. So that's the AMD, the 8088, that's a 16-bit computer. No, that's a 16-bit CPU. I'm not going to take it out, and even this 8186 I got there, that's a 16-bit. And the 8286 and the 8386, but only the SX, not the 8386DX. And I think we have 8386DX2, I'm not sure. That's probably 32 bits, so that's we're going to read about now. That's some waterproof for my cell phone. I have to, I need to get out on the water again, even in a rubber boat or sub paddleboard. You can get a paddleboard. It's like a surfboard. That's a surfboard. You're standing on top of a surfboard and paddle. You can get it inflatable, you can get it with air. I'd like to buy one of this, so I need some waterproof to have my wallet and cell phone. But this is only 3 pages, so actually I don't understand why they're so short. But that's not so many have read about it. So I will go back to my bed, so this will be a short a video in one part, but some of this PDF can be many pages, like 30 or 40, takes just 2 hours. This is why I'm used to talk few minutes before I start the video. I normally talk few minutes because some can be like 50 pages or 20-30 pages. Read to the end of documents.
32-bit computing. In computer architecture, 32-bit integers, memory addresses, or other data units are those that are 32 bits, 4 octets, wide. Also, 32-bit central processing unit, CPU, and arithmetic logic unit, ALU, architectures are those that are based on registers, address buses, or data buses of that size. 32-bit microcomputers are computers that use 32-bit microprocessors. Contents. Range for storing integers. Technical history. Architectures. Applications. Images. File formats. See also. References. External links. Range for storing integers. A 32-bit register can store 232 different values. The range of integer values that can be stored in 32 bits depends on the integer representation used. With the two most common representations, the range is 0 through 4,294,967,295, 232 for representation as an unsigned binary number, and 2,147,483,648, 231, through 2,147,483,647, 231 for representation as 2's complement. One important consequence is that a processor with 32-bit memory addresses can directly access at most 4 GB of byte addressable memory, though in practice the limit may be lower. Technical history. The world's first stored program electronic computer, the Manchester Baby, used a 32-bit architecture in 1948, although it was only a proof of concept and had little practical capacity. It held only 32-bit words of RAM on a Williams tube, and had no addition operation, only subtraction. Memory, as well as other digital circuits and wiring, was expensive during the first decades of 32-bit architectures, the 1960s to the 1980s. 1. Older 32-bit processor families, or simpler, cheaper variants thereof, could therefore have many compromises and limitations in order to cut costs. This could be a 16-bit ALU, for instance, or external, or internal, buses narrower than 32 bits, limiting memory size or demanding more cycles for instruction fetch, execution or write back. Despite this, such processors could be labeled 32-bit, since they still had 32-bit registers and instructions able to manipulate 32-bit quantities. For example, the IBM System /360 Model 30 had an 8-bit ALU, 8-byte internal data paths, and an 8-bit path to memory, 2, and the original Motorola 68000 had a 16-bit data AL1 and a 16-bit external data bus, but had 32-bit registers and a 32-bit oriented instruction set. The 68000 design was sometimes referred to as 16/32-bit. 3. However, the opposite is often true for newer 32-bit designs. For example, the Pentium Pro processor is a 32-bit machine, with 32-bit registers and instructions that manipulate 32-bit quantities, but the external address bus is 36 bits wide, giving a larger address space than 4 GB, and the external data bus is 64 bits wide, primarily in order to permit a more efficient prefetch of instructions and data. 4. Architectures. Prominent 32-bit instruction set architectures used in general-purpose computing include the IBM System /360 and IBM System /370, which had 24-bit addressing, and the System /370XA, SR /370, and ESA /390, which had 31-bit addressing. The December VAX, the NS320XX, the Motorola 68000 family, first two models of which had 24-bit addressing, the Intel IA 32-bit version of the x86 architecture, and 32-bit versions of the ARM, 5, SPARC, MIPS, PowerPC and PowerISC architectures. 32-bit instructions A architectures used for embedded computing include the 68000 family and Coldfire, x86, ARM, MIPS PowerPC, and Infineon Tricore architectures. Applications. On the x86 architecture, a 32-bit application normally means software that typically, not necessarily, Uses 32-bit linear address space, or flat memory model, possible with the 80,386 and later chips. In this context, the term came about because DOS, Microsoft Windows and OS/2.6 were originally written for the 8088/8086 or 80,286, 16-bit microprocessors with a segmented address space where programs had to switch between segments to reach more than 64 kilobytes of code or data. As this is quite time-consuming in comparison to other machine operations, the performance may suffer. Furthermore, programming with segments tend to become complicated. Special far and near keywords or memory models had to be used, with care, not only in assembly language but also in high-level languages such as Pascal, compiled BASIC, Fortran, C, etc. The 80,386 and its successors fully support the 16-bit segments of the 80,286 but also segments for 32-bit address offsets, using the new 32-bit width of the main registers. If the base address of all 32-bit segments is set to 0, and segment registers are not used explicitly, the segmentation can be forgotten and the processor appears as having a simple linear 32-bit address space. Operating systems like Windows or OS/2 provide the possibility to run 16-bit, segmented, programs as well as 32-bit programs. The former possibility exists for backward compatibility and the latter is usually meant to be used for new software development. Images. In digital images /pictures, 32-bit usually refers to RGBA color space, that is, 24-bit true color images with an additional 8-bit alpha channel. Other image formats also specify 32 bits per pixel, such as RGBE. In digital images, 32-bit sometimes refers to high dynamic range imaging, HDR, formats that use 32 bits per channel, a total of 96 bits per pixel. 32-bit per channel images are used to represent values brighter than what sRGB color space allows, brighter than white. These values can then be used to more accurately attain bright highlights when either lowering the exposure of the image or when it is seen through a dark filter or dull reflection. For example, a reflection in an oil slick is only a fraction of that seen in a mirror surface. HDR imagery allows for the reflection of highlights that can still be seen as bright white areas, instead of dull gray shapes. File formats. A 32-bit file format is a binary file format for which each elementary information is defined on 32 bits, or 4 bytes. An example of such a format is the enhanced meta file format. See also 64-bit computing. History of video games, 32-bit era. Word, data type. Physical address extension, PAE. References. 1 Patterson, David, Ditzel, David, 2000.
This, but I like to scroll to the end of the line. That was from 24 April. Last edit. So that was not about 32 bits computing, but that depends how many write about it. So I will upload this, but I think should do the next, the x86 architecture. This one, the x86 architecture for the modern the 16-bit and 32. Probably I need that. I don't have it on my list, but I have a lot of stuff I don't have on my list, all about the DOS and Windows and gaming computers, because that took a lot of hours to make this list. I cannot make a full list with like 500 PDF. I just follow my list for now. But I think we should do the the x86 architecture should do that. So I have to write it down. This I use it on my notes. So by now it's 1:30 p.m. No, I use this small notes. I use it when I go to my computer, need for the title. 32 bits. No, probably should find should find this x86 architecture. But first I have to drag this 32-bit computing, drag it to my finished reading folder. Let's find this x86 probably we need to do that. That's 30 pages. But that's about how a computer is working. I don't have it on my list, but I think we should do it. That's 30 pages, so this can take really a long time. Bits, or maybe we should wait to do it. Actually, we just need, I think we should wait to do it. Let's do the 64 bits. Let's finish the 64 bits. I think we should do that. Open, let's just follow the list, but let's do the 64 bits. That's 16 pages. Then we can do this x something there. I can write it here. We can make a small corner there. Do it, call it 15.1. 15.1 x86. Just make a small corner there. But there's a big mess my list, so I just don't have more space, so the paper is totally weird notes all over. But this one is 16 pages, that will take a long time to read, and the next one is the X. That's 30 pages, so but I think we could finish this today. Do the 64-bit computing and do this one. So, but now I need to upload. My alarm clock is on. Let's move my gamer keyboard. And let's get something to drink. We have 1 minute left. I think we should do some lemonade. So I have to spend, if I have a bit time left on the video, like I should do stuff like this if I like to record. So I'm not spending too much time in the next video. But I like to talk a few minutes, like just 2 minutes, just to say hi and talk a bit before I record. So, but this computer PDF, that's not only just about this PDF, that's about me and my daily life. But we have to stop the video because it's splitting in half a minute. So let's continue, let's upload this.